All right, guys, so this is the start of Chapter 12, and Chapter 12 is our statistics unit. So some of you are really, this is just going to click with you and you're going to go with it. And then others, it's going to be a little more difficult, but push through, do your homework honestly, don't rely on Slater, ask questions, and you'll be fine, and you'll get this down before we test over it. All right. So this is the first section, which is just kind of the general idea and some vocab. We're going to talk a lot about sample spaces and just theoretic probability and things like that. All right, so a probability experiment is simply an action or trial that has varying results. So it can go one way or another, or it can go 6 ways or whatever. So an example of this, let's just say we are flipping a coin twice. 2 times to see whether it lands on heads or tails. Okay, so we're going to do this trial, or we're going to do this probability experiment. We're going to flip a coin 2 times just to kind of see, does it land on heads 2 times, tails 2 times, one of each? All right, so the sample space is the set of all possible outcomes. Okay, so how could this happen? So if I flip a coin twice, okay, and I'm curious, does it land on heads or tails? Well, it could land on heads the first time and heads the second time. Or it could land on heads the first time and tails the second time. Or it could land on tails the first time, heads the second time, or tails the first time and tails the second time. Okay, so the collection of all 4 of these is the sample space. Okay, it's the sample space for this probability experiment. Okay, the outcome. It's a single possible result of a probability experiment. So any one of these could happen. Okay, so one of these would be an outcome. Okay, so I'm going to write each of the 4 individually is an outcome. So let's say I want to know what's the probability it'll land on heads both times. Okay, heads both times or heads heads would be the outcome. Okay, an event. An event is a collection of one or more outcomes in a probability experiment. So say we want to know if it's tails, tails, or heads, heads. Say we want to know if it lands on the same thing both times. Okay. So this would be event if we're seeing if both flips land or resulted, I like that better, resulted in the same side. Tails, tails, or heads, heads would be the event. So the probability of event is the measure of likelihood or chance that it will occur. So I could say that the probability of heads, heads, or heads, tails is 2 over 4, which equals 1 over 2. Or you could also write it as 0.5 or also as 50%. Okay, you see all of these when you're talking about probability. All right, so let's look at this. It says, in an experiment, 3 coins are flipped. List the possible outcomes in the sample space of the experiment. So how could these land? Well, let's write them out. And the key to this is writing them out systematically so you have some type of system so you don't overlook one. So maybe we just get 3 heads. Or maybe we get 2 heads. So 2 heads could be heads, heads, tails. Or heads, tails, heads. Or tails, heads, heads. Okay, so maybe we get all 3 heads. Maybe we get 2 heads. Maybe we only get 1 head. So head, tail, tail. Tail, heads, tails. Or heads, tails, tails. Or maybe we get no heads, which would just be tails, tails, tails. 1, 2, 3, 4, 5, 6. So there's a total of 8 events in the sample space. Okay, so if it says to list the sample space, you have to list all of these. All right, let's do another example. Now, I know your sheet printed out black and white, so you can't see these. So I just put red, yellow, green, and blue. So when you refer back to them, you can kind of know what you're talking about. Okay, so now we're going to flip this. And we want to list all the outcomes. So here it's not heads or tails. Here it's green, red, yellow, or blue. So there's 4 possible outcomes in this sample space if we spin it 1 time. Okay, so say we spin it twice. Okay, let's say we spin blue first. So we can go blue, blue. We can go blue, red, blue, yellow, or blue, green. Or maybe we spin green first. So we'd have green, blue, green, red, green, yellow, green, green. Or maybe we do yellow first. So yellow, blue, yellow, red, yellow, 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 green. Last but not least, maybe we do red first. So red, blue, red, 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 yellow, or red, green. Okay, so there would be 16 outcomes here. Now, if we spun it 3 times, okay, we're not going to write all these out, but I can tell you if we did, and if you want to go for it, go for it. There's 64 possible outcomes if we spin it 3 times. All right, I want you to go ahead and list all possible outcomes in the sample space. Now, I don't want you to write this out unless you really want to. I can tell you there is 216 possible outcomes here. So there's 216 in the sample space. But I do want you to do A and B, and then we'll go over it. All right, so what you should have gotten is if you roll 1 6-sided dice, there's 6 possible outcomes in the sample space. It'd be 1, 2, 3, 4, 5, or 6. You can roll any of these numbers when you roll it once. Okay, so let's look at B. Now we roll 2 6-sided dice. So we could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. Or the first roll could be a 2, 2, 1, 2, 2, so on and so forth. So on this one, there would be 36 outcomes in this sample space. All right, so the theoretical probability is the ratio of number of favorable outcomes when all outcomes are equally likely. Okay, so like heads or tails, we have a 50-50 chance. So 50% would be the theoretic probability. Okay. All right, let's look at this example here. It says, in an experiment, a spinner is spun. How many ways can you spin a 1, 2, 3, 4, 5? So let's do 1. How many different ways can we spin it? Well, there's a 1 here. So there's only 1 way to spin a 1. Okay, what about a 2? Well, there's 2 ways to spin a 2. 3, we have 1, 2, 3 ways to spin a 3. 4, we have 1, 2 ways to spin a 4. And 5, we have 1, 2, 3, 4 different ways we can choose a 5. Okay, now the sample space then would be, and this might be a little confusing, so we could have a 1, or remember we have 2 2s, so 1 comma 2 comma 2, 3 3s, so 3 3 3, 2 4s, 4 4, and 4 5s, so 5 5 5 5. Remember, there are 1 2 3 4 5 6 7 8 9 10 11 12. I think 12 outcomes in the sample space. So when we write the sample space, we have to write 12 different things. Okay, even if they're the same, it's a possible outcome. Okay, so what is the total number of outcomes? I should probably 1 2 3 4 5 6 7 8 9 10 11. Yeah, I counted right. There are 12 possible outcomes. All right, so let's look at example 3B. This one requires a little more thought. All right, so a student is taking a quiz and randomly guesses the answers to 4 true or false questions. Okay, what is the probability of the student guessing exactly 2 correct answers? Okay, so when I write this, I would write this as, and this is a whole different notation, and we'll continue doing it so you'll get used to it, the probability of 2 correct. We would write it like that. Okay, and like I said, we're going to do this a whole lot, so it's okay if you're not comfortable with it. All right, so take note that we're not talking about did they answer true or false. We're talking about did they answer correct or incorrect. Okay, so if they answered 0 correct, that means the first has to be incorrect, second is incorrect, third is incorrect, and the fourth is incorrect. Okay, if they answered 1 correct, maybe the first one was correct. Maybe the second one was. Maybe the third one was. Or maybe the fourth one was. Well, maybe they answered 2 correct. So correct, correct, incorrect, incorrect, correct, incorrect, correct, incorrect, correct, incorrect, incorrect, correct. Or incorrect, correct, incorrect, correct, incorrect, incorrect, correct, correct. Whew, that's a mouthful. Okay. Am I missing one on there? I am missing one. The 2 middle ones could be correct. Okay, now what if 3 were correct? Well, that would mean 1's incorrect. Or what if I answered 4 correct? There's just 1 way, correct, 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 correct. Okay, so there is a total of 1 way to answer all of them incorrect. 1, 2, 3, 4 ways to answer 1 correct. 1, 2, 3, 4, 5, 6. 6 ways to answer 2 correct. 4 ways to answer 3 correct. 1 way to answer 4 correct. Okay, so what is the probability of the students not, oh, first what is the probability that they have exactly 2 correct answers? So the probability of 2, well, there's 6 ways we could have 2 correct, so it'd be 6 out of, and then if we add all these up, 1, 5, 5 plus 6 is 11, 15, 16, 6 out of 16, which is 3 out of 8. Okay, so what is the probability of students not guessing exactly 2 correct? Well, that would be this one. 1 plus 4 is 5. 5 plus 4 is 9, 10. So it'd be 10 out of 16, which is 5/8. And I want you to look at the 3/8 and the 5/8. And is it coincidental that they both add to 1?